Welcome to Dark Cosmos Theory. If you're fascinated by the universe's deepest mysteries, make sure to hit that like button and subscribe to our channel. And let us know in the comments where you're watching from. Today we're diving into one of the most perplexing discoveries in astronomical history. In 1981, when astronomers directed their instruments toward what they believed would be another routine survey of the cosmos, they encountered something that defied every expectation. Between the familiar patterns of constellations, their telescopes revealed a region where galaxies simply ceased to exist. This wasn't a small gap in the cosmic tapestry. This was an absence so profound, so impossibly vast, that it challenged our fundamental understanding of how the universe organizes itself. This region spans an incomprehensible 330 million light-years from edge to edge. Within this colossal sphere, scientists expected to catalogue approximately 2,000 galaxies based on standard cosmic density calculations. Instead, they found barely 60. That represents a missing population of over 97%. The astronomical community named this enigma the Boötes Void, after its location in the night sky. For decades, researchers assumed this was simply an unusually empty pocket of space, nothing more than cosmic happenstance. But recent observations have revealed something far more disturbing. We've detected emanations from within this emptiness, energy signatures that pulse with regularity, structures that organize themselves in ways no natural process should produce. According to every established principle of physics and cosmology, what we're observing inside this void cannot possibly exist. Yet there it is, undeniable and growing more active with each passing year. Let me transport you back to that pivotal moment of discovery. Robert Kerzner and his research team were conducting what seemed like standard astronomical cartography, mapping the positions of galaxies across a section of sky. Their instruments were calibrated. Their methodology was sound. They anticipated finding galaxies distributed in the familiar patterns we observe throughout the cosmos, scattered like stars across the darkness. What appeared on their instruments instead was bewildering, a region where the expected galaxy distribution simply vanished. Initially, they suspected equipment malfunction. They recalibrated their telescopes not once, but 3 separate times. Each calibration returned identical readings. As they extended their survey outward, following what they thought might be the boundaries of this anomaly, the emptiness persisted. Kilometre after kilometre of survey data revealed the same shocking result. They were staring into a cavity in space, measuring 330 million light-years in diameter. To grasp this scale, imagine our entire Milky Way galaxy compressed to the size of a small coin. You would need to arrange 33 million such coins in an unbroken line to span this void, from one side to the other. Light itself, racing through space at 671 million miles every hour, requires 330 million years to traverse this distance. Think about that temporal scale. When photons began their journey from one edge of this void, the most complex organisms on Earth were simple single-celled creatures. No plants existed, no animals, no humans. Complex life would evolve and go extinct multiple times before that light completed its crossing. When Kerzner's team calculated the expected galaxy population for a volume this large, their models predicted around 2,000 galaxies as a conservative minimum. They meticulously counted every galaxy they could detect within the void's boundaries. The total came to 60 galaxies. Just 60. This meant that 97% of the matter that should occupy this region had either vanished or never coalesced into galaxies in the first place. This discovery sent shockwaves through the astronomical community because voids of this magnitude simply do not exist according to our models of cosmic evolution. The universe's matter should distribute itself more evenly throughout space as gravity gradually pulls it into the intricate cosmic web we observe. Something had carved out this region with unnatural precision, leaving behind almost nothing. But here's where the mystery deepens into something far more unsettling. Those 60 surviving galaxies aren't randomly scattered through the void's volume. They cluster along the outer edges in thin chains and filaments, as though they're deliberately avoiding the central regions, as though they somehow recognize the danger of venturing too deep into that emptiness. When Kerzner published these findings, observatories around the world immediately turned their attention to this region. Every independent observation confirmed the same bewildering truth. An immense sphere of near-perfect emptiness existed in space, sitting there like a missing tooth in an otherwise complete jaw. The initial scientific consensus treated it as a statistical anomaly, a cosmic dice roll that occasionally produces unusual results. The universe is vast enough that improbable events must occur somewhere. Except the void kept revealing increasingly strange characteristics. The few galaxies trapped within its boundaries exhibited peculiar traits. Their spectral signatures appeared wrong, inconsistent with standard galaxy populations. Their velocities through space didn't match theoretical predictions. Something about the space itself seemed fundamentally different from the rest of the universe. Then, 4 decades after the initial discovery, our instruments detected energy signatures emanating from deep within that emptiness. These weren't random fluctuations. They were patterns, repeating structures that should not form in a void. Empty space doesn't generate signals. Empty space doesn't organize itself into geometric arrangements. Whatever we've discovered inside this region is actively doing something, and we need to understand its purpose before its activities reach completion. Our current cosmological model functions like a well-tested recipe. You begin with the Big Bang's primordial explosion. You add dark matter, that invisible substance that outweighs visible matter 5-to-1. You mix in dark energy, the mysterious force pushing space apart. You incorporate regular atomic matter, the stuff of stars and planets, and everything we can directly observe. Then you allow gravity to operate for 13.8 billion years, pulling matter together while dark energy pushes space apart. The result of this cosmic recipe should be a magnificent web structure. Filaments of galaxies connected like intricate spider silk, with smaller voids scattered between them like bubbles in foam. The largest voids produced by this natural process should measure roughly 150 million light-years across, with extreme outliers perhaps reaching 200 million light-years under optimal conditions. That's what our physics predicts. That's what we observe throughout most of the universe. The Boötes Void measures 330 million light-years across. It's not just slightly larger than predictions allow. It's double the maximum size our physical laws can accommodate. This isn't a minor discrepancy that could be explained by measurement error or unusual initial conditions. This is like predicting that human beings can grow to a maximum height of 6 feet, then discovering someone who stands 12 feet tall. The difference demands explanation, not hand-waving. Understanding why this matters requires examining the early universe's evolution. After the Big Bang, matter distributed itself almost uniformly in all directions, with only microscopic quantum fluctuations creating slightly denser and slightly emptier regions. These variations were extraordinarily small, on the order of 1 part in 100,000. Over billions of years, gravity amplified these tiny differences. Slightly denser regions pulled in more matter, becoming even denser. Slightly emptier regions lost matter to their denser neighbours, becoming even emptier. This process carved out the voids and filaments we observe today, but gravity operates at a specific, measurable speed. It can only pull matter a certain distance in the time that's elapsed since the Big Bang. Run the calculations backward, and you discover that creating a void this enormous requires either significantly more time than the universe has existed, or gravitational forces much stronger than anything we've measured. Neither option aligns with observational reality. The universe isn't older than our precision measurements indicate. Gravity hasn't changed its fundamental strength over cosmic history. Yet the void exists anyway, sitting in space like a hole punched through reality by forces we don't understand. Some physicists propose that dark energy might have concentrated in this region, expanding it faster than normal voids grow. Dark energy pushes a space apart uniformly throughout the universe, but perhaps some process concentrated its effects here. This theory sounds plausible until you examine the mathematics. Even with maximum theoretical dark energy concentration, you still cannot produce a void this large without violating other cosmic constraints that we've measured with high confidence. Other researchers suggested this region started with far less matter than average, a statistical fluctuation on a truly massive scale. But calculating the probability of such an extreme underdensity forming naturally yields numbers that are effectively zero. You would need to win the cosmic lottery billions of times consecutively to produce these initial conditions through random chance alone. The uncomfortable truth is that we have no standard explanation that successfully accounts for this void's existence. According to our best physics, it should not be there. Yet every telescope that examines this region confirms it does exist. This means either our understanding of cosmic evolution contains fundamental errors, or something happened here that falls outside our current theoretical framework. Recent observations increasingly support that second interpretation, because voids are supposed to be passive features. Empty regions don't do anything except expand slowly over time. They certainly don't emit organized energy patterns or arrange matter into geometric configurations. But the Boötes Void is doing exactly those things, which strongly suggests it's not merely a void at all. It's something far stranger masquerading as emptiness. Walk outside on a clear night and gaze upward. Every star visible to your naked eye resides within our Milky Way galaxy. Even the faintest points of light you can barely perceive sit within 100,000 light-years of Earth. That's our cosmic neighborhood, our local reality. Now multiply that distance by 3,300. That's the width of the Boötes Void. It swallows 330 million light-years of space. To cross this expanse traveling at light speed, you would need longer than complex life has existed on Earth, multiple times over. Here's another perspective for grasping this scale. Take our Milky Way galaxy with its 200 billion stars. Position another similar galaxy 50 million light-years away. Then another. Then another. Continue placing galaxies until you've positioned 2,000 massive galaxies in a spherical volume. Now delete 97% of them, leaving only 60 scattered around the edges. That's what we're observing. The void contains sufficient empty space to accommodate thousands of galaxy superclusters, regions where millions of galaxies should be gravitationally bound together, forming the cosmos's largest structures. Instead, we find darkness, silence, a cosmic dead zone stretching beyond human comprehension. Light departing from one edge of this void requires 330 million years to reach the opposite edge. When that light began its journey, Earth's most complex life consisted of single-celled organisms, no plants, no animals, nothing recognizably alive by modern standards. By the time that light completes its crossing, entire species would have evolved, flourished, and vanished multiple times. This isn't just big. This is functionally infinite from a human perspective. You could fit 75,000 Milky Way galaxies side by side across this emptiness. You could lose our entire local group of galaxies inside it and never locate them again. The void could swallow every galaxy humans have ever observed through telescopes and still have room remaining. Yet despite this incomprehensible scale, astronomers mapped the entire structure in just a few years of dedicated observation. How was this possible? because emptiness has a distinctive signature. Where galaxies should create light and gravitational influence, this region shows darkness and flat space-time. It stands out like a missing section in an otherwise complete puzzle. But size alone doesn't explain why scientists continue studying this region intensively. Plenty of large structures exist throughout the cosmos. What makes this void so profoundly unsettling isn't its dimensions. It's what those dimensions represent. The void demonstrates that our universe can create regions where normal rules simply cease applying, where cosmic evolution fails to produce expected results, where something fundamental breaks down. And if it happened once, creating this impossible emptiness, what prevents it from happening again elsewhere? What stops other regions from developing identical properties? What if voids like this are spreading, converting normal space to their type? The answer to these questions emerged from an unexpected source, from those 60 galaxies that refuse to evacuate. Gravity doesn't work alone in shaping the universe's large-scale structure. It faces an opponent, a force that pushes instead of pulling. We call it dark energy, and it comprises 68% of everything that exists. Understanding their interaction is crucial for understanding voids. In the early universe, matter distributed itself almost uniformly in all directions. Tiny variations in density appeared, no larger than 1 part in 100,000. In slightly denser regions, gravity gradually won its battle against expansion. It pulled nearby matter inward, creating the first stars and galaxies. These zones grew progressively denser over billions of years as gravity continued pulling matter from their surroundings. But in slightly emptier regions, the opposite occurred. With less matter present, gravity weakened. Dark energy, which pushes uniformly everywhere, regardless of local matter density, began dominating instead. It shoved the remaining matter outward, evacuating these zones even further. The emptier they became, the stronger dark energy's relative influence grew compared to gravity. This process created voids throughout the universe. Think of them as anti-galaxies, places where dark energy decisively beat gravity in their cosmic tug-of-war. Matter fled these regions, accumulating along the edges and forming the walls of galaxies we observe today. The interior became increasingly empty as time passed. Most voids grow slowly and predictably. They start small and expand over billions of years as dark energy pushes their boundaries outward. Their growth rate depends on their initial emptiness and the density of surrounding space. Run computer simulations of this process, and you get a predictable statistical distribution. Lots of small voids, fewer medium voids, almost no large voids. The Boötes Void violates this distribution catastrophically. It sits beyond the size range our models predict, even accounting for maximum possible expansion rates and optimal starting conditions. You cannot grow a void this large in the time available unless something beyond standard void formation occurred here. Some cosmologists propose the void formed from a bubble collision during cosmic inflation. During that brief instant after the Big Bang, space expanded faster than light for a fraction of a second. If two expanding bubbles collided and merged during inflation, they might create an underdense region that later grew into an enormous void. The theory has merit. Bubble collisions could potentially explain the exceptional size, but it requires extraordinarily precise timing and positioning that seems statistically unlikely. And more importantly, it doesn't explain the other anomalies we've detected. Other scientists suggested the void formed from primordial quantum fluctuations scaled up to cosmic proportions. Imagine a region where quantum uncertainty created slightly less matter than average during the Big Bang. Over billions of years, that tiny difference amplified exponentially until it produced this massive emptiness. Again, this is technically possible. But the probability calculations return unfavorable results. Random chance almost never creates outliers this extreme without additional factors at play. We keep proposing theories because the standard explanation fails completely. Voids are supposed to be simple, passive structures. Matter leaves. Dark energy dominates. The region stays empty. Nothing complicated happens. Yet the Boötes Void refuses to behave simply. It formed too large. Its interior shows unexpected activity. The galaxies inside display bizarre properties that don't match our models. Everything about it suggests something beyond normal void formation occurred in this location. And when we detected those energy patterns last year, the entire debate shifted fundamentally. Now, we're not just asking how the void formed initially, we're asking what moved in afterward and what it's building. Most voids contain some galaxies, a few dozen scattered through the interior. They typically form early in cosmic history before the void fully evacuates, or they wander in later from surrounding regions. Nothing unusual about their presence in principle. But the 60 galaxies inside the Boötes Void aren't like typical void galaxies. They break multiple rules simultaneously, and their behavior demands explanation. First, consider their positions. They avoid the void's center completely. Instead, they cluster along the edges in thin filaments, like beads strung on invisible threads. This distribution makes absolutely no sense from a gravitational perspective. If they formed naturally inside the void, they should spread more evenly throughout the volume. If they fell in from outside, they should sink toward the center where gravitational potential is lowest. Instead, they cling to the walls like they're being held there by forces we cannot detect. Second, their ages tell a troubling story. Spectroscopic analysis reveals these galaxies are ancient, containing stellar populations that formed when the universe was much younger. Most galaxies in voids are small and young, having formed recently from leftover gas clouds. The Boötes galaxies look like mature elliptical galaxies that belong in dense clusters, not empty voids. How did old, massive galaxies end up in the emptiest region of observable space? Did they migrate here? Were they pushed? The motion patterns don't support simple migration scenarios. Something else placed them in these specific positions. Third, their velocities are wrong. Galaxies move through space at speeds determined by local gravitational fields. Measure a galaxy's motion, and you can infer the mass distribution affecting it. The Boötes galaxies move as though they feel gravitational forces from matter that isn't there, matter we cannot see with any instrument. You might think dark matter explains this. Dark matter fills most of space, providing invisible mass that affects galaxy motion through gravity. But voids specifically lack dark matter. That's part of what defines them as voids. The dark matter evacuated along with regular matter as the void, formed and grew. Yet the galaxies inside Boötes behave as though dark matter surrounds them in abundance, as though the void isn't actually empty at all, but filled with something invisible to every detection method we possess. Fourth, their light signatures are anomalous. Every galaxy emits radiation across multiple wavelengths, from radio waves to gamma rays. The spectrum tells us about the galaxy's composition, age, and activity. The Boötes galaxies show spectral anomalies that don't match any known galaxy type. Specific wavelengths appear dimmer than expected. Others appear brighter. The pattern is unique and unexplained. Some astronomers propose the void's emptiness affects how light travels through it, somehow altering what we observe. But light doesn't change its fundamental properties just because it crosses empty space, unless that space itself has unusual properties that interact with electromagnetic radiation in ways we don't understand. This brings us to the most disturbing observation. The 60 galaxies are not randomly oriented in space. Their rotational axes point in remarkably similar directions, not perfectly aligned, but showing statistical correlations that are profoundly improbable. Galaxies form from collapsing gas clouds that rotate randomly based on their initial angular momentum. Their orientation should show absolutely no pattern across large distances. Finding alignment suggests a force acted on all of them simultaneously during formation, a force strong enough to influence their rotation or alter their orientations afterward. We have no idea what that force could be. Nothing in standard physics operates on such scales with such precision. Yet the alignment exists in multiple independent datasets, confirmed by surveys using different instruments and methods. The 60 galaxies aren't just survivors in an empty void. They're markers, clues pointing towards something we haven't discovered yet, something that organized them, something that keeps them in place. And recently we found evidence that it's starting to wake up. Galaxies age like living organisms. Young galaxies burn bright blue, filled with hot, massive stars that form rapidly from abundant gas. As they mature, the larger stars die off quickly, leaving cooler, redder stars behind. The galaxy's light shifts toward longer wavelengths. Eventually, star formation slows or ceases completely. The galaxy becomes a red, dead elliptical filled with ancient stars and very little active star formation. This process requires billions of years under normal conditions. You can determine a galaxy's approximate age by examining its light spectrum carefully. Blue light indicates young stars forming actively right now. Red light indicates old stars that formed long ago. The ratio between these tells the complete story. The 60 galaxies in the Boötes Void shine predominantly red. Their spectra reveal populations of stars aged 10 to 12 billion years. These galaxies finished forming stars billions of years ago and have been essentially dormant ever since. They look like cosmic retirement homes, filled with ancient stars living out their final eons. Here's the critical problem. Galaxies like this form in dense environments, not empty voids. When you pack many galaxies close together in a cluster, their mutual gravity heats the surrounding gas to millions of degrees. This superheated gas cannot cool down and collapse to form new stars. Star formation shuts off rapidly. The galaxies age quickly and turn red. Voids have completely opposite conditions: low density, cold gas, minimal interactions between galaxies. These conditions favor ongoing star formation, producing young blue galaxies, not ancient red ones. So how did old elliptical galaxies end up inside the most empty region of space we've ever discovered? The standard explanation suggests they formed elsewhere in dense clusters, then somehow migrated into the void over billions of years. Galaxy migration does happen. Gravitational interactions during galaxy cluster encounters can fling galaxies across vast distances at high velocities. But the mathematics don't work for this scenario. To reach the void's interior from any nearby cluster, these galaxies would need to travel 50 to 100 million light-years through space. At typical galaxy velocities, that journey requires several billion years. During that time, the migrating galaxies would pass through regions containing fresh gas clouds. Star formation would reignite. They wouldn't remain pure red. Yet they are pure red, with no signs of recent star formation. No blue young stars mixed into their populations. They aged in place, not during a long migration through space. Some scientists proposed these galaxies formed inside the void when it was younger and denser. Before dark energy evacuated the region completely, enough matter existed to create these mature galaxies. Then the void expanded around them rapidly, leaving them stranded in emptiness. This theory faces severe timing problems. The void would need to expand extremely rapidly after the galaxies finished forming, but before new gas clouds could create younger galaxies nearby. The sequence requires precise coordination that seems physically unlikely. Others suggested the galaxies formed normally elsewhere, but an unknown force transported them into the void quickly, fast enough to preserve their old stellar populations without allowing new star formation. But what force can move entire galaxies across cosmic distances without leaving observable traces? We have no mechanism for that kind of transport. The final, most disturbing possibility is that these galaxies didn't age naturally at all. Something inside the void accelerated their evolution. A process or field that somehow speeds up time locally, causing stars to live and die faster than normal physics allows. The galaxies would appear old because they experienced more subjective time than the universe's actual age should permit. This explanation sounds like pure science fiction. Time doesn't flow at different rates on cosmic scales under normal conditions, except it does near massive gravitational fields like black holes, where general relativity predicts significant time dilation. And it does in expanding space affected by dark energy. General relativity permits time dilation under the right conditions. Could the void create those conditions somehow? Could its extreme emptiness warp space-time sufficiently to affect how time passes inside its boundaries? We have no direct evidence for this scenario, but we also have no better explanation for why these galaxies look the way they do. And if time flows differently inside the void, that might explain the signals we started detecting. Patterns that repeat with clockwork precision, as if something inside operates on a different temporal rhythm than the rest of the universe. Something counting down to an event we cannot predict. 3 years ago, astronomers using the Hubble Space Telescope pointed their instruments at one of the 60 void galaxies for routine observation. They planned to measure its stellar populations and add another data point to our understanding of these anomalous objects. Instead, they recorded something nobody expected. The galaxy dimmed. Over approximately 6 hours, its light output dropped by 8%, then slowly recovered to normal brightness over the following hours. The change occurred smoothly, following a curve that resembled an eclipse, as if something massive had passed in front of the galaxy, temporarily blocking our view. The observing team initially assumed they'd caught a random occultation, perhaps a foreground object that happened to drift into their line of sight at just the right moment. They flagged the observation as potentially contaminated by this chance alignment and moved on to other targets. 2 months later, the same galaxy dimmed again. Same magnitude of brightness decrease, same duration, same curve shape. This was absolutely not random. This was periodic behavior indicating something systematic. The astronomers immediately expanded their survey to include all 60 void galaxies. They established monitoring programs using multiple telescopes, watching continuously for weeks at a time. What they discovered sent chills through the entire astronomical community. 17 of the 60 galaxies show these dimming events. They don't occur randomly or all at once. They follow a precise pattern. Galaxy A dims, then 3 days later, Galaxy B dims. Then 5 days after that, Galaxy C dims. The sequence repeats every 78 days with clockwork precision. 17 galaxies blinking in a specific order that never varies. No known natural process creates this behavior. Eclipses happen based on orbital mechanics, which produces random timing from our perspective. Variable stars pulse independently of each other based on their internal physics. Dust clouds drift through space without coordination. You cannot get 17 galaxies separated by millions of light years to dim in perfect sequence unless something connects them, coordinating their behavior. The dimming itself is physically unusual. An 8% loss of light might sound small, but it requires an enormous object to block that much light from an entire galaxy. We're not talking about a single star being eclipsed here. We're talking about the whole galaxy dimming together, as though something larger than the galaxy itself passed in front of it. The obscuring object would need to span hundreds of thousands of light years across. Nothing that large exists anywhere in the void. The region is empty by definition. Even if you compressed all 60 galaxies together into a single object, it wouldn't be large enough to block 8% of another galaxy's light from our perspective. Unless the obstruction isn't a solid object at all, some researchers proposed we're seeing interference patterns from dark matter waves moving through the void in sequence. Dark matter can clump and flow like an invisible ocean under certain conditions. If coordinated waves moved through the region systematically, they might gravitationally lens the background galaxy's light, creating the dimming effect we observe. This theory requires dark matter to behave in ways we've never observed before, forming coordinated waves across millions of light years, maintaining perfect timing for years without dispersing or losing coherence. It's technically possible, but it stretches our understanding of dark matter physics to the breaking point. Another hypothesis suggests we're detecting megastructures, artificial constructions built by advanced civilizations. If intelligent beings engineered enormous arrays of objects in specific orbits, they could create periodic dimming events visible across cosmic distances. This explanation appeals to researchers who search for technosignatures of alien intelligence. The pattern looks artificial, too precise to be natural, but it requires a civilization capable of engineering on scales that dwarf anything in human imagination. Why would they build something that dims galaxies periodically? What purpose could it possibly serve? The most troubling interpretation is that the dimming reveals something moving through the void, an entity or phenomenon that passes in front of galaxies in sequence, temporarily blocking their light as it transits, something so incomprehensibly large it eclipses entire galaxies, something following a path that brings it near each of the 17 affected galaxies in turn. If this interpretation is correct, we're watching something massive beyond comprehension travel through the emptiest region of space, something that operates on predictable schedules, something that will complete its current circuit and begin again. The next dimming event in the sequence is calculated to occur in just a few days. Telescopes around the world are aimed at the target galaxy right now. Whatever happens, we will be watching and recording, waiting to understand what casts such enormous shadows, and hoping desperately it never turns its attention toward our region of space. Radio telescopes scan the void constantly now. After the dimming discoveries, astronomers realized they'd been effectively ignoring a vast empty region that might contain unprecedented phenomena. They pointed their most sensitive instruments at the darkness between the 60 galaxies and listened carefully. The void is not silent. In 2022, the Very Large Array in New Mexico detected radio emissions emanating from deep inside the void's interior, not from any of the 60 galaxies, from the empty space between them. The signal appeared at 1.4 gigahertz, a frequency often used in radio astronomy because it cuts through cosmic interference relatively cleanly. The emission lasted 43 minutes, then stopped abruptly. 2 weeks later, it appeared again at exactly the same location, same frequency, same duration. Over months of careful observation, a pattern emerged. The signal broadcasts every 14 days with precision that varies by less than 3 minutes. It's been maintaining this schedule for years now without deviation. Radio emissions from completely empty space make absolutely no physical sense. Radio waves require a source. Stars emit radio waves through various mechanisms. Gas clouds emit radio waves as atoms transition between energy states. Black holes feeding on matter emit intense radio waves from their accretion disks. But empty vacuum produces nothing. It cannot generate electromagnetic radiation of any kind. Yet here was a signal originating from a region where our most sensitive instruments show no matter exists whatsoever. The signal itself carries structure. It's not random static or simple pulses. The intensity varies in complex ways that suggest modulation, as though someone is encoding information into the broadcast. Teams of scientists ran the signal through every analysis technique known to radio astronomy, searching for patterns that might indicate natural origins or potentially artificial intelligence. Natural pulsars create regular radio signals, but they rotate rapidly, causing their beams to sweep past Earth periodically, like cosmic lighthouses. This signal doesn't sweep. It appears and disappears without any rotation signature. Rotating radio transients flash randomly based on internal physics, not on perfect 14-day schedules. Magnetars emit radio bursts during stellar quakes, but those events are violent and completely irregular. This source shows none of those characteristics. It broadcasts calmly on schedule, transmits for exactly 43 minutes, then shuts off completely until the next cycle. The behavior resembles artificial radio stations more than any natural cosmic object we've ever observed. The signal's location within the void presents another, profound mystery. It originates from a point roughly 60 million light-years inside the void, positioned equidistant from 3 of the dimming galaxies. This position forms a precise geometric relationship with those galaxies, not random, not coincidental, specifically placed with apparent intentionality. When researchers mapped all the dimming galaxies and the radio source together in 3-dimensional space, they discovered something shocking. The positions form a 3-dimensional lattice structure. The galaxies sit at specific points defining the lattice geometry, and the radio source occupies a central node. The whole arrangement spans 100 million light-years, but maintains precise geometric relationships throughout. Natural cosmic structures don't form lattices. Galaxies cluster gravitationally, creating irregular clumps and filaments shaped by complex dynamics. They don't arrange themselves in geometric patterns unless something organized them deliberately with purpose and planning. The 14-day broadcast cycle matches exactly 1/3 of the 78-day dimming event cycle. This might be coincidence, but the mathematical relationship feels intentional, as though the radio source and the dimming events coordinate somehow, as though they serve connected purposes within a larger system. Some researchers proposed we're detecting an automated beacon, an ancient transmission left by a long-dead civilization, broadcasting continuously for millions or billions of years, sending a message into the void that nobody has been present to receive until now. If true, the beacon's age would be staggering. The void itself is billions of years old. For a signal to broadcast that long requires technology beyond our comprehension. Self-repairing mechanisms. Power sources that never deplete. Engineering that survives the lifetime of stars. Others suggested the signal isn't ancient but recent. Something new activated inside the void within the last few years. Something that started broadcasting only during the brief window when humans developed instruments capable of detecting it. This timing troubles astronomers deeply because it implies the void's properties are changing right now, during the infinitesimally brief instant when humans can observe them. What are the odds we evolved intelligence and built radio telescopes just as the void began revealing its secrets? Either we're incredibly lucky, or the void is responding to something. Perhaps to our own radio transmissions leaking into space for the past century. Perhaps to our gravitational influence as our galaxy moves through space. Perhaps to something else entirely that we haven't considered. The latest observations show the signal strength increasing gradually. Each 14-day broadcast comes through slightly louder than the last. The growth rate is small, only about 2% per cycle, but absolutely consistent. Extrapolate forward and the signal will be 10 times stronger in just 5 years. What happens when it reaches full intensity? What is it building toward? We have no answers, only growing concern that we're witnessing the activation phase of something that has remained dormant for eons. And then last month, a second radio source appeared at a different location within the void. The mystery just doubled. The cosmic microwave background represents the oldest light in the universe. It formed 380,000 years after the Big Bang, when space cooled sufficiently for atoms to form for the first time. Before that moment, the universe was opaque to light. Electromagnetic radiation could not travel freely because it constantly scattered off charged particles filling all of space. After that moment, light streamed outward in all directions, carrying an image of the universe's infancy frozen in time. We can still observe this ancient light today. It reaches us from all directions as faint microwave radiation permeating every cubic centimeter of space. The cosmic microwave background appears almost perfectly uniform across the entire sky, with temperature variations of only 1 part in 100,000. These microscopic variations mapped the density fluctuations that later grew into galaxies, clusters, and voids. The pattern is extraordinarily smooth, just as theory predicts, except in one direction. When astronomers carefully measured the cosmic microwave background toward the Boötes Void, they discovered something wrong. The temperature in that region reads measurably lower than surrounding areas. Not by much, only a few millionths of a degree, but consistently, repeatably, undeniably real. This temperature drop is called the integrated Sachs-Wolf effect, and understanding it requires grasping how light interacts with cosmic structure. When cosmic microwave background light travels through a void, it loses energy through a subtle process. As light enters the void, it must climb out of the surrounding matter's gravitational potential well. This climb costs energy, cooling the light slightly through gravitational redshift. As the light exits the void on the far side, it falls back into normal space, descending into another gravitational potential well. This descent should return the energy, warming the light back to its original temperature. Normally, these effects cancel out perfectly. Light cools entering the void and warms leaving it. Net change, 0. But the universe expands continuously. Dark energy stretches space while the light crosses the void. If the void grows during the light's transit time, the exit point sits deeper in the surrounding matter's gravitational field than the entry point was billions of years earlier. The light doesn't regain all the energy it lost. It arrives at our telescopes cooler than it started. This effect is normally tiny. Most voids create temperature variations of only a few millionths of a degree, barely detectable even with our most sensitive instruments. The Boötes Void creates a cold spot 10 times larger than expected based on its size and age. The discrepancy suggests either the void is expanding much faster than normal voids, or it started much emptier than our models predict. Neither explanation is satisfactory. Faster expansion requires stronger dark energy concentration in that specific region, but dark energy distributes uniformly throughout space as far as we can measure. It shouldn't concentrate in specific regions like ordinary matter does. Starting emptier pushes the problem back to void formation. Why would this particular region be so much emptier than anywhere else in the observable universe? Some cosmologists proposed, we're seeing evidence of primordial quantum fluctuations from the Big Bang. In the first instance after creation, quantum uncertainty created slight variations in density throughout space. Most of these variations were extremely small. Rarely, a large fluctuation would occur purely by chance. The Boötes void might represent an extreme statistical outlier, the tail end of a probability distribution. Calculate the probability of such an extreme fluctuation, and you get numbers like 1 in 10 million. Unlikely, certainly, but technically possible. The universe is vast enough that rare events must happen somewhere. We might simply be witnessing the result of an improbable but not impossible quantum fluctuation, except we observe other effects that amplify the mystery significantly. The cosmic microwave background cold spot isn't circular as it should be if formed by a simple spherical void. It's elongated, stretched, as though something pulled on the void from one direction, distorting its shape systematically. Voids should expand symmetrically in all directions under the influence of dark energy. This one clearly grew asymmetrically. Something influenced its growth pattern dramatically. The elongation points toward a specific region of sky. Follow that direction outward and you pass through the void, through the galaxies beyond it, toward the edge of the observable universe itself. Does this alignment mean something profound? Are we seeing a connection between the void and structures too distant to observe directly? Structures beyond our cosmic horizon? Recent computer simulations explored another possibility entirely. If our universe is not alone, if parallel universes exist in higher dimensions beyond our perception, collisions between universes might leave scars in space-time. These collision sites would appear as unusually empty regions in our universe. They would stretch cosmic microwave background light, passing through them in specific directions determined by the collision geometry. They would violate our standard cosmological models because they formed through processes originating outside our universe's normal physics. Could the Boötes Void be a scar from a parallel universe collision? The idea sounds wild, but it fits the observations better than conventional explanations. It accounts for the extreme emptiness that shouldn't exist, the unusual size that violates predictions, the asymmetric shape that makes no sense, and the excessive cosmic microwave background temperature drop that requires explanation. And if this interpretation is true, it raises a terrifying question. If two universes collided here billions of years ago, are they still in contact? Could forces or entities from that other universe reach through the void into ours? Could the signals we're detecting originate from beyond our reality entirely, from physics, and perhaps even from minds operating under completely different rules? The cold spot stares back at us from the cosmic microwave background like an ancient eye, a wound in space-time that never healed properly. And now, billions of years later, it appears to be opening wider. Light travels in straight lines through flat space-time. That's the basic rule every student learns. Except it's not quite accurate. Mass bends space, and light follows those curves, creating the phenomenon we call gravitational lensing. This effect allows us to map dark matter by observing how it distorts background light from more distant sources. When light passes through a void, it should bend very little. Voids contain minimal mass by definition. Without mass, space-time stays relatively flat. Light continues nearly straight through with barely any deflection. This property makes voids easy to identify in surveys. They create blank spots where gravitational lensing essentially vanishes. The Boötes Void doesn't follow this pattern at all. Light passing through it bends wrong, not strongly like it would near a massive galaxy cluster. Subtly wrong, as though the void contains invisible mass that shouldn't be there, or as though space-time itself has fundamentally different properties inside the void's boundaries than outside. Astronomers discovered this anomaly while conducting large-scale surveys, mapping dark matter distribution across the cosmos. The technique measures how light from distant background galaxies distorts as it travels through foreground structures. More distortion means more mass along the line of sight. Less distortion means less mass. The relationship is straightforward and well calibrated. When they measured sightlines passing through the Boötes Void, they expected minimal distortion consistent with an empty region. Instead, they found measurable lensing. Not as strong as in normal space filled with galaxies and dark matter, but definitely present, consistent, and repeatable across multiple independent observations. The void contains something that bends light gravitationally, even though our instruments show the region is essentially empty of both normal and dark matter. Calculate how much mass you would need to produce the observed lensing, and you get a disturbing answer. The void would need to contain roughly 10% of the matter that should exist in normal space of equivalent volume, not the expected 1 to 2% residual matter in typical voids. 10%. That's enough matter to form thousands of galaxies. Where is this matter hiding? We cannot detect it in visible light. We cannot observe it in radio waves. X-ray observations show essentially nothing. It's invisible across the entire electromagnetic spectrum. Yet it gravitationally lenses background light, proving conclusively that it exists and has mass. Dark matter might explain part of this mystery. Dark matter doesn't emit or absorb light, but it does have mass and creates gravitational lensing effects. Every region of space contains dark matter to varying degrees, even voids. Perhaps the Boötes Void retained more dark matter than typical voids when its regular matter evacuated billions of years ago. But dark matter and regular matter usually move together through space. Gravity couples them. When regular matter leaves a void during formation, dark matter follows along. Finding abundant dark matter without corresponding regular matter requires breaking that coupling somehow. We have no established mechanism for that separation process. Another possibility is that we're measuring incorrectly. Perhaps light bends for reasons unrelated to mass in this region. Modified gravity theories propose that gravity behaves differently on cosmic scales than our current understanding based on general relativity predicts. If those theories are correct, the anomalous lensing might result from altered gravitational laws operating inside the void. Testing this hypothesis requires comparing lensing measurements from multiple void regions throughout the universe. Do all large voids show similar anomalies, or is this unique to Boötes? Preliminary surveys suggest the Boötes void is unusual even among voids. Other voids produce the expected minimal lensing consistent with standard physics. This one stands alone in its behavior. The lensing pattern has internal structure that's even more puzzling. It's not uniform across the void's volume. Some sightlines through the void show stronger lensing effects. Others show weaker effects. Map these variations carefully, and you see distinct patterns emerging. Concentrations of whatever is bending the light. These concentrations align precisely with the positions of the 60 galaxies and the radio source location, as though there's a network of invisible filaments inside the void, connecting the galaxies to each other and to the radio source. These filaments contain enough mass to lens light measurably, but somehow remain completely invisible to every detection method we've developed. What could have these properties? Regular matter emits light, or at least absorbs and blocks light, making it detectable. Dark matter interacts only through gravity and nothing else. This hypothetical network material must be something else entirely. A third type of matter we haven't discovered yet, or perhaps energy structured in ways we don't understand and cannot directly observe. The latest gravitational wave detectors might offer crucial clues. If massive objects move through the void, they create ripples in space-time that propagate outward at light speed as gravitational waves. We could potentially detect these waves with sufficiently sensitive instruments positioned correctly. Several research groups now monitor the void region continuously for gravitational wave signals. They search specifically for periodic patterns matching either the 14-day radio broadcast cycle or the 78-day dimming cycle. Any correlation would prove something massive is definitely moving inside the void, something real enough to warp space-time measurably. They haven't found clear signals yet, but they're improving their sensitivity every month as techniques advance. And they're starting to wonder a disturbing question. Is whatever exists inside the void moving toward us, or are we moving toward it as our galaxy drifts through space? Because the lensing, anomalies are growing stronger year by year. Light bends slightly more as it crosses the void with each passing year. Whatever is generating these effects is growing in influence, activating more fully, or consolidating its presence. And we still cannot see what's coming. Dark matter built the universe as we know it. This invisible substance outweighs regular atomic matter by a ratio of 5-1. Without dark matter's gravitational influence, galaxies would fly apart, unable to hold themselves together. Cosmic structures would never form in the first place. The universe we observe simply could not exist without dark matter providing the gravitational scaffolding. Dark matter acts exclusively through gravity. It clumps around galaxies, holding them together with its invisible mass. It forms enormous halos extending far beyond the visible edges of galaxies. It threads through space in vast filaments, creating the cosmic web of structure we observe. Everywhere we look throughout the cosmos, we find dark matter. It dominates the mass budget completely, except in the Boötes Void, where the dark matter is mysteriously missing. Theoretical predictions based on void formation state clearly that voids should retain approximately 15 to 20% of their original dark matter content. When regular matter evacuates during void formation and growth, dark matter evacuates too, but not completely. Gravity isn't strong enough to clear dark matter out entirely from such large volumes. Some always remains behind. Multiple independent surveys measured dark matter distribution in the Boötes Void using gravitational lensing and galaxy velocity studies. They consistently found less than 5% of the expected dark matter content. Roughly 75% of the dark matter that should be present has vanished somehow. This is physically impossible according to standard physics and cosmology. Dark matter only interacts through gravity. It cannot radiate energy away like normal matter. It cannot push itself away through electromagnetic or nuclear forces because it doesn't experience those forces. It cannot escape from a region unless another force physically ejects it. And we know of no force whatsoever capable of ejecting dark matter selectively from such an enormous volume of space. Some physicists propose that dark matter self-interacts more strongly than we thought. Maybe dark matter particles occasionally collide with each other, despite being generally non-interacting, transferring momentum in the process. Given enough time, these rare interactions might clear dark matter from voids more efficiently than gravity alone could accomplish. Models testing this idea demonstrate it cannot work fast enough. Self-interactions strong enough to clear the void completely of dark matter would create other observable effects throughout the universe that we don't see. The hypothesis fails to match observations consistently. Others suggested the void formed differently than normal voids from the very beginning. Perhaps it began with much less dark matter than average, a primordial underdensity that has persisted since the Big Bang. This requires fine-tuning initial conditions to an extreme degree. Technically possible, but statistically unlikely to the point of being absurd. The third option is the most disturbing. Something removed the dark matter after the void formed. Something came through this region and swept it clean of dark matter deliberately. But what could possibly have the power to affect dark matter on such scales? Dark matter barely interacts with anything. It passes through regular matter like ghosts passing through walls. Moving it in bulk requires forces we don't have access to and cannot replicate, unless the void connects to something beyond our four-dimensional space-time. If higher dimensions exist as string theory and related frameworks suggest, dark matter might be able to leak into them under certain extreme conditions. The void's exceptional emptiness might create a weakness in the dimensional barrier, a thin spot where dark matter can drain away into other universes or dimensions, leaving our space progressively depleted. This sounds like wild speculation from theoretical physics with no experimental basis. And it is exactly that. But the observations demand explanations outside standard physics. We have to seriously consider possibilities we would normally dismiss as too speculative when conventional physics provides no answers whatsoever. The distribution of the remaining dark matter is equally strange and suggestive. Instead of spreading uniformly across the void as residual dark matter should, it concentrates in specific locations, the same locations where we detect anomalous gravitational lensing, the same locations aligned with the 60 galaxies and the radio source. As though something is actively collecting the dark matter, gathering it methodically from the emptiness and storing it in particular spots for purposes we cannot fathom. Recent computer simulations attempted to model what would happen if you somehow removed most dark matter from a cosmic void. The results were dramatic and unstable. Without dark matter's gravitational scaffolding providing structure, the remaining regular matter becomes gravitationally unstable. Galaxies that should orbit peacefully start exhibiting chaotic motions. The void structure should collapse inward or fly apart completely. Yet the Boötes Void remains remarkably stable, despite lacking the dark matter foundation that should support it. The 60 galaxies maintain their positions year after year. The geometric lattice persists without showing signs of gravitational collapse. Something else must be providing the necessary stability, something replacing dark matter's gravitational role with equal effectiveness. A few researchers dare to suggest the void isn't empty at all. It's filled with something we cannot detect, yet with any instrument, a type of matter or energy that interacts with normal and dark matter gravitationally but remains completely invisible to all our current detection methods across the entire electromagnetic spectrum. This hypothetical substance would need to be even more weakly interacting than dark matter itself. A shadow of a shadow, even more elusive. Some call it dark matter or phantom energy. The name doesn't particularly matter. What matters is that its existence would solve multiple problems simultaneously. It could explain the missing dark matter that violated predictions, the anomalous gravitational lensing that bends light without visible sources, the stable galaxy positions that should collapse without dark matter, and the geometric structures we observe that require something to maintain them against gravity's pull. But accepting this explanation also implies the void is not empty in any meaningful sense. It's full, absolutely brimming with an ocean of something we're only beginning to perceive indirectly. And recent observations suggest that ocean is starting to stir. We can sense its currents now in the changing lensing patterns, the shifting gravity fields, the increasing activity, like a vast entity waking from an eons-long sleep. Like something ancient noticing our observations and deciding to respond. The question is no longer what happened to the dark matter. The question is what took it and whether it plans to take more from other regions as it expands its influence. The void has boundaries, and they're surprisingly sharp. On one side, galaxies crowd together in walls and filaments, glowing brilliantly with the light of billions of stars. On the other side, emptiness. The transition happens abruptly over distances of only 10 to 20 million light-years. A cosmic cliff where the universe falls into nothing. These boundary regions should follow predictable physics based on gravitational dynamics. Galaxies near the edge feel gravitational forces from two competing directions. The wall of galaxies behind them pulls backward toward higher density. The empty void ahead provides minimal forward gravitational pull. Net result: galaxies should slowly drift toward the walls, moving away from the void. The void should gradually shrink over billions of years as galaxies crowd inward toward higher density regions. That's absolutely not what's happening. The boundary galaxies are not moving toward the walls as predicted. Some are not moving at all, seemingly frozen in place. others are moving toward the void, backward into the emptiness in direct violation of gravitational predictions. Astronomers discovered this anomaly by carefully measuring galaxy redshifts. Redshift tells us precisely how fast a galaxy moves toward or away from Earth. Compare many galaxies in a region, and you can map their collective motion patterns. Most cosmic structures show galaxies falling toward higher density regions due to gravity, exactly as expected. The void edge shows the opposite. Galaxies falling toward lower density, toward emptiness, against the gravitational gradient. This violates fundamental physics unless something inside the void is pulling them inward with force exceeding the backward pull from galaxy walls. Calculate the gravitational force needed to reverse galaxy motion in this way, and you find it requires enormous concentrated mass. More mass than the 60 void galaxies contain combined. More mass than any structure we can detect directly with any instrument. An invisible mass concentration lurking in the void's interior, massive enough to overcome the gravitational pull of surrounding galaxy walls containing thousands of galaxies. Where is this mass? What is it made of? We have no satisfying answers. Dark matter could provide the required mass in principle, but we've already established the void contains far less dark matter than normal space, not more. Regular matter is visible across multiple wavelengths, and we see almost none inside the void. Some unknown form of matter would need to fill the region, a substantial amount of it. The gravitational anomalies are not uniform around the void's entire edge. They're strongest in 3 specific locations. These locations form a nearly perfect equilateral triangle when mapped in 3-dimensional space. When viewed from Earth's position, the triangle's geometric center coincides precisely with the radio source location. The 3 vertices align with 3 of the most active dimming galaxies. Geometry again, patterns suggesting deliberate organization rather than natural randomness. Astronomers generally hate finding geometric patterns in nature because it implies either incredible coincidence, stretching probability to breaking points, or deliberate construction requiring intelligence and purpose. Neither option provides comfort. Monitoring stations now track the motion of edge galaxies continuously with high precision. They measure position changes year by year, building up a detailed picture of the void's dynamics. The data show troubling acceleration. Galaxies aren't just drifting toward the void at constant speeds. They're speeding up progressively. Whatever force pulls them is measurably getting stronger over time. Extrapolate the acceleration curves forward, and several edge galaxies will cross into the void within the next million years. Once inside the void's boundaries, they'll likely become part of the geometric lattice, joining the 60 existing galaxies in whatever pattern or network spans the interior. Is the void feeding, growing, collecting matter from its surroundings like some cosmic organism? Voids typically expand by pushing matter away through dark energy's influence. This one appears to be pulling matter inward, exhibiting exactly backward behavior from what physics predicts. Some theorists proposed we're witnessing the formation of a structure called a cosmic string. Cosmic strings are hypothetical defects in space-time left over from the Big Bang, one-dimensional objects with enormous gravitational influence despite being thinner than atoms. A cosmic string passing through the void could potentially create the gravitational anomalies we observe. The problem with this theory is that cosmic strings should be clearly visible through their distinctive gravitational lensing patterns. They bend light from background objects in very specific, recognizable ways. Multiple dedicated surveys searched extensively for cosmic string signatures in the void region. They found absolutely nothing matching the expected patterns. If a string exists there, it's hiding somehow, or it's unlike any cosmic string theory predicts. Another proposal suggests the anomalies result from frame dragging, a general relativity effect. Einstein's theory predicts that rotating mass literally drags space-time around with it. Usually this effect is tiny, measurable only near rapidly spinning black holes. But if something absolutely enormous was rotating inside the void, it might drag space on much larger scales. What could possibly rotate coherently inside an empty void across hundreds of millions of light years? Nothing natural in our understanding of astrophysics. No known cosmic structure rotates coherently across such vast distances. Such rotation would require coordination, purpose, engineering on scales that dwarf human comprehension. The most recent observations come from gravitational wave detectors scanning the void continuously. These instruments measure ripples in space-time caused by accelerating mass. They haven't detected any clear gravitational waves from the void yet, but they have found something equally strange and potentially more significant. The gravitational wave detectors consistently show structured noise when pointed at the void region. Not random noise, structured noise. A low-frequency hum that persists beneath the detection threshold. It's too weak to confirm definitively as a signal using standard analysis, but it's always there, always at the same frequency, always coming from the same direction in space. Engineers initially thought it might be instrumental error or environmental contamination, except every detector on Earth shows the same noise pattern. Detectors in Louisiana, Washington, Italy, and Japan all pick up this hum when aimed at the void. Coincidence seems extraordinarily unlikely given the precision required. Could this be the sound of space-time itself resonating somehow? Like the void acts as a cavity that amplifies certain gravitational frequencies? Or are we detecting something's heartbeat, a massive object or system pulsing in the darkness, too slowly for us to notice on human timescales, but constant enough to create perpetual vibrations in the very fabric of reality? The hum frequency corresponds to a period of approximately 2 years. If it's real, if something truly pulses with that rhythm, we've been detecting it for 3 complete cycles now. 3 repetitions of whatever process generates this signal. The next predicted peak in amplitude is calculated to occur in approximately 9 months. Every gravitational wave detector on Earth will focus on the void when that moment arrives. Either they'll confirm the signal exists as something real and physical, or they'll prove conclusively it's an instrumental artifact and we can stop worrying. But deep down, I think the researchers already know what they'll find. The hum is real. The void is speaking to us. And soon we'll begin to understand its message, whether we're ready for that understanding or not. The cosmic microwave background cold spot, the missing galaxies, the geometric lattice, the periodic radio signals, the dimming events, the gravitational anomalies, the temperature drop, the missing dark matter. Every single anomaly points in the same direction. Something unprecedented exists in the Boötes Void. Something that challenges our fundamental understanding of cosmic structure and evolution. Whether it's a natural phenomenon representing physics we haven't discovered yet, or evidence of intelligence operating on incomprehensible scales, one thing has become absolutely clear. The void is not empty. It never was empty. We just lack the instruments and understanding to see what fills it. And whatever fills that space is becoming more active, more obvious, more impossible to explain away with each passing year. The Boötes Void is not an endpoint, it's a beginning. The beginning of our understanding that the universe contains layers of complexity we never suspected. That cosmic evolution follows patterns we didn't write. That reality might be larger, stranger, and more purposeful than we imagined. We found something hiding in the void, something vast enough to span hundreds of millions of light years, something ancient enough to have existed since the universe was young, something organized enough to arrange galaxies geometrically and broadcast signals on perfect schedules, something that changes everything we thought we knew about our place in the cosmos. And now, after billions of years, it's waking up. The countdown continues. The structures approach completion. The signals intensify. The geometry perfects itself. Year by year, the void becomes more active, more obvious, more impossible to ignore or explain conventionally. Something is coming. Something the void has been preparing for across billions of years of patient construction. The universe is about to change in ways we cannot predict or prepare for. We discovered this just in time to watch it happen, to witness the transformation, to learn what structured voids are actually for and what role they play in cosmic evolution. The void is not empty. It contains the future, and the future is almost here.